Good evening, everybody. It's about 10 p.m. here Eastern Daylight Time. I'm student meteorologist Eric Drewitz with Weather International, and this video is the first video of a new series that I like to begin. It has a goal for both a personal goal and a community goal, which is to convey forecast concerns and weather impacts to the general public in a much better fashion. And from the wonderful opportunity that I've had this whole summer, one of the key things I've learned is that communication is very important in the field of meteorology. So this video is part of a personal goal that I have, which is to improve my speaking skills, vocal skills, not stuttering as much, and also conveying weather impacts and phenomena and forecast concerns to the general public in a much more understandable fashion. And to get started here, I guess, I will explain a few of the terms I had in the previous technical video that I'm sure that not a lot of people have heard that much before. So upper level energy was the first one, which is obviously, in my opinion, one of the most important ones, if not the most important. And what that means is it's also known as vorticity to start off with in meteorology class, which is the technical definition is the ability for the atmosphere to spin up, if you will. So the best way to picture in your head is think of yourself at the beach or at a pool, and you're splashing around in the water, and you kind of move your hand like that through the water and make a wave. Well, that's kind of like what this upper level energy does to the air, because the air just acts like a fluid, just like water, you know. So what it does is it's a forcing mechanism for storm formation because your environment or conditions outside can be favorable for storms. However, if there's nothing to force storms, if there's nothing to force upper motion or air rising, you're not going to get the storms to form. So that's obviously the best way I could describe upper level energy. Now, talking about CAPE, I also mentioned CAPE, and that's pretty much just a measure of atmospheric instability or how unstable the air is. Uh, and pretty much that means the higher the number or the higher the CAPE value, the more unstable the air is, the atmosphere is. And then I also mentioned SIN, and SIN, what it is pretty much the lock on the door um, for storm formation, essentially. So pretty much the more SIN you have, the less likely storms will form. And that's because SIN prevents particles from reaching their LFCs, or the level of free convection, which is essentially the door uh, for storm formation. Because once parcels surpass their level of free convection, they're going to rise until they get to their equilibrium level, most likely. So, the SIN is pretty much the lock on that door to prevent storm formation. Uh, and the wind shear is another term I used, and that pretty much is to it means the change in wind directions or speed, or a combination of the both, um, with height most of the time is what we look at. So, you know, we have more change in the wind. So the greater the shear, the more the wind is changing with height is better for thunderstorm formation, especially supercells and tornadoes. However, there's a lot of storms on the synoptic scale or the larger scale, such as nor'easters, which are the big East Coast snowstorms, or hurricanes, or even on the mesoscale, lake effect snow bands. Those kind of scenarios, you want less shear, or you don't want the winds to change so much as with height. Otherwise, those storm systems will get ripped apart. Now, getting into the forecast concern, so central Pennsylvania, western New York, and central New York regions have the potential threat for decent thunderstorms on Monday afternoon into the evening. And due to what I described in the video before, for example, to start off with low level moisture with dry air aloft, or in other words, moist air below dry air, that's unstable. And the best way to think about it is think about a glass of water with ice cubes, and the water being the dry air and the moist air being the ice cubes, because moist air is less dense than dry air. So with dry air being denser, it should be below the moist air. So with dry air below moist air, it's like you're having uh, ice cubes floating on water. But if you take an ice cube and you push it to the bottom of the glass, and it'll pop right back up at you, that's an example of dry air aloft or dry air on top of moist air, because the moist air is less dense and the dry air is more dense. And usually materials in all of science, doesn't matter physics, chemistry, the denser the material is, it's below a material that's less dense. So due to that density difference, you're going to have rising motion with low level moisture and dry air above, um, because less dense materials like to be on top of more dense materials, just how nature works. So that was a big portion of the forecast concern throughout the region, with 700 millibar moisture less than 850 millibar moisture, and 850 millibars is below 700 millibars because pressure decreases with height, as we all know. But getting back into the forecast concern, we had lots of instability, low level moisture, and we did have that upper level energy like I described to literally force it. So you literally have air that's gonna, unlock the door to that level of free convection. So you're gonna have air that's gonna unlock the door for the parcels to essentially ascend to the heavens, as a lot of us meteorologists say. A lot of us meteorologists say, you know, forgive your sin and ascend to the heavens. No pun intended. And so the chances for thunderstorms throughout the central Pennsylvania, western New York, and central New York regions for Monday afternoon, because of this scenario, are very likely. So if you have any additional concerns, questions, comments, I'm very open to feedback on this. My goal, again, is to really improve my skills. I'm going to really strive to improve, my communication skills during my senior year, because I really want to be the best meteorologist I can be. So this has been my first video to address, concerns for the general public, and this is student meteorologist Eric Drewitz with the Weather International signing off here. Have a wonderful evening and a wonderful night, everyone. Stay safe out there.